Alright, let's look at the homework 2, problem number 18. Alright, so given this quadratic function, we want to find the intercept, vertex, maximum or minimum, and range. Alright, so let's do that. Alright, first we're going to write it in vertex form. Alright, so first thing I would do is I would factor out the coefficient of the leading term, so 0.5. From the first two terms. Alright, so if you pull out 0.5 from 0.5x squared, you have x squared left over. And if you pull out 0.5 from negative 4x, you're going to have a negative 8x. So same as multiplying by 2. Right? Then I'm going to leave plus 12 right at the end. So I'm going to put here. Right? Then we need to find out the third term we need to complete the square. To do that, all you have to do is take this number and divide by 2 and square that number. So divide by 2, then square that number. Right? So divide by 2, so you have negative 4. Negative 4 squared would be 16. So you would need positive 16 here, right? But since we added positive 16 there, I'm going to subtract the 16 right away so that we don't change the function, right? So we're going to use these three terms to complete the square, right? So we're going to get here 0.5 is still there, so we have to have that there, right? So this is going to be x, right? Then you take the 1/2 of negative 8, so it's going to be negative 4 squared. Right? Then one thing we have to be careful is that you have a leftover negative 16. You would have to still distribute 0.5 to this term to get it out of the parentheses. So 0.5 times negative 16 would be negative 8. So it's going to be negative 8. And then you have, we still have plus 12. So plus 12. All right. So you have 0.5 times quantity x minus 4 squared. And then you have a plus 4. All right. So let's type it in. All right, so we have a 0.5 quantity x minus 4 squared and plus 4. All right, and check the answer. All right, we got that. All right, so let's find the y-intercept and probably x-intercept too. All right, so in order to find y-intercept, so this is going to be part A. All right, so if you want y-intercept, and we're going to set x equal to 0. All right, so we know that we just have to evaluate s of 0. All right, and this is actually easy to evaluate. The 0, first term is 0, x is 0, so second term is 0, so this is going to be 12. All right, so let's type that in, and y-intercept is 12. All right, check the answer. All right, we got that. All right, then we want to find x-intercepts. All right, so let's do that. All right, then we have this x-intercept. Then we notice that maybe we should do this. If you look at the ballpark picture, all right, so this is a parabola, and since the leading coefficient is positive, so it's facing upward, so it looks like this. All right. And this would be a part B question, but the vertex is at here. Vertex is at here. This is a shift to the right 4 units, so it's going to be 4, comma. This is 4, so upward 4, 4, 4. All right. So the lowest value is actually positive 4, which means that the x-axis is actually below this parabola. So this parabola never touches the x-axis, which means that there's no x-intercept. Right? So there's no x-intercept. Right? So that would be the answer here. Right? There are no x-intercepts. Right? So check the answer. Right? We got that. Right, then vertex is, so we already know vertex is 4, 4, right? So from that picture, so 4, 4, and check the answer. Right, we got that. And does the function have a minimum or maximum? Right, so again, parabola is facing upward, so it's going to have a minimum value. So it's going to be a minimum value. Right, then check the answer. We got that. And the minimum value is, since vertex is at the 4, 4, so y coordinate is 4, so it's going to be the 4. Right, so we got that. Right, the range is going to be, right, so since we know that the range here, so lowest value is -4, the range is going to be starting from positive 4 and up. Right, so let's type it in. All right, oops, let's see here. All right, so starting from positive 4, including 4, then infinity. All right, so let's check the answer. All right, we got that. All right, that's it. I hope that this was clear.